Greetings to you. Welcome once again to Physics with Ben. Don't forget to subscribe and share this video to those that need it. If you are a returning subscriber, welcome back once again. God bless you. This is the second video series on reflection of light at curved mirror surfaces. In the previous video, we looked at reflection on the convex mirror surface and then concave mirror surface. The rules for drawing ray diagrams, and we drew a ray diagram where the object was placed between C and Earth. Today I want us to look at a few more ray diagrams and also calculations on this topic. Stay tuned and God bless you. Ray diagrams and calculations on reflection of light on concave mirror surface. In that video, I also told you the application of concave mirror. That's the concave mirror can be used to cook your food. Remember the concave mirror cooker I showed you? Go and construct one. So let's begin. Today, I want us to draw a ray diagram. We place today our objects at C. Our objects in front of C or beyond C. And then I'll leave you with the rest as your assignment, and then we'll do some little calculations that are very, very captivating. So let's go straight to the point. Don't forget, the first things first in drawing ray diagrams is for you to draw your horizontal line first. I'm drawing from this the 50, I will extend it. This is from 0 to 50. So this is, I have chosen 10 to draw my line of symmetry. You may choose 0 to 15 and choose 5 or 3, or 5 as a line of symmetry. So do it, just step it down. And so the center from here to here to 50, the center is simply this is 5, this is 5, 10, 15, 20. So 30 is the center. So I will bring out my ruler right now. So from here to here is 10, from here to here is 20, from here to here is 20. So this is my focal point, and this is my center of curvature. And so I will draw my line of symmetry here quickly. Good. And then I will draw my supposed concave mirror. And then this is the reflecting side. And then this point is the pole of the mirror. From here to here is the aperture of the mirror. Let's call it AB, the aperture of the mirror. And then we'll extend this line here to help us outline everything in this mirror. And so I said that from here to this point, from the pole of the mirror to this point, is called the focal length of the mirror. The focal length of the mirror is the point where the rays of light after reflection at the mirror surface will converge. For the concave mirror, if you put your hand here, your hand may catch fire. So that is the reason why this guy can be used to cook, as I showed you in the other video. So from here from here to center of curvature is your radius of curvature. And so you need 2f to get 1r. And then your f is just r all over 2. Note that. Now, in the other video, we placed our object here. And then the image was formed here. And then it was magnified. The reason why I'm taking time to explain this geometry is that you don't need to cram this thing. Just get hold of the geometry. This is a heartbeat of the topic. Once you get hold of this, you can draw any ray diagram. And then you can state any characteristics of the image formed. So today, we are going to place our objects at C. Now, if my geometry is very correct, which may not be accurate, the image must be formed at C. When objects are placed at C, the image is always formed at C. So let's see if I'll be a little bit careful to see if it will be formed here. So I want to measure my image and my object height to be 10 cm. So you may choose your object height to be 4 cm. So my object height is 10 cm. Now, don't forget there are 3 rules. A ray of light passing parallel to the principal axis after reflection, it must pass through this space, through the principal focus. A ray of light passing through the principal focus, after reflection, it must pass parallel to the principal axis. A ray of light passing through the center of curvature, after reflection, it will return to the same place undeviated. So, let's apply rule number 1. I told you don't put it like this, not like this, but make sure it's very straight. Good. So, a ray of light passing parallel to the principal axis, after reflection, it must pass through the focal point. So, good. After reflection, it must pass through this place. So this is the arrow out. Good. Let's apply the other rule. A ray of light passing through the principal focus of the mirror, after reflection, a ray of light passing through the focal point of the mirror, after reflection, don't forget I said don't put it like this. Don't put it like this. Make sure it is perfectly horizontal. I told you my geometry will not be that precise, but if you do it correctly, the image will be formed at C. And then the reason why my image is not forming at C here is because of the aperture of the mirror. The mirror is not, I was supposed to do something like this, not too curved like this. So right now my image disappointed me, and instead of forming at C, it forms slightly behind C, which is not too wonderful. My geometry is not perfect. Ideally, if you draw it correctly, your image, this line of intersection is supposed to be directly under C. Yes. However, let's manage this one. So this is where your image is, and we measure it. Here was 10. Let's see. Whoa. The image is exactly 10 cm. The image formed is exactly 10 cm. But then upside down. The image form is also what? So say that the image height is also what? 10 cm. However, the position is the only change that we have there. So the properties of the image formed, the characteristics of image. Number one, the image is inverted. The image, right, image inverted. Number two, image is same size as the object. Number three, image. Now, the image is supposed to form at C. So I'm writing that the image is formed at C. The reason why I'm writing that is what must happen. And I've told you the reason why this image is not formed here. If I draw something like this, maybe a little more careful to draw something like this. Good. My image would have been formed directly here, but then the surface is too curved. So just write image is what? Formed at C. Number four, image is real. If you put your screen here, that is where the image will be captured. So, as I said in the other video, from here to here is your object distance. From here to this point, to this particular point here, in this case, this point is your image distance. That is that for that. So you can place your object in front of C at F, between F and C. So I don't want us to waste more time. I believe with this video and the other one, you now have a holistic knowledge on how to draw your ray diagrams correctly. So let's go straight to the second part of this lesson. We want to do some ray calculations right now. I am making use of two textbooks here. Complete workbook in physics by Ashegun A.O. my very good friend. Please get a copy of this book. Click in the description box below to get the contact of the author so you can place your order. And then I'm making use of this particular book. So I want to pick like 2-3 questions here for us to solve quickly. Complete workbook in physics by Ashegun A.O. Book 2, page 86 and page 87. Or let's start from page 85. An object, question number 8 from his book. An object is placed 20 cm in front of a concave mirror. So when I'm saying this now, you'll be referring to the diagrams we have drawn in the other videos, and then you'll not be confused again. So when I say an object is placed 20 cm in front of a concave mirror, meaning that is the object distance. So our U is 20 cm, and our F, focal length. An object is placed 20 cm in front of a concave mirror, or focal length 15 cm, full stop. Calculate the position of the image formed and the magnification. So, the position F is given as 15 cm. Position of the image formed simply means V, image distance V is not given, and what N is what not given. So let's go straight to the point. Solution. From 1 all over F is equal to 1 all over U plus 1 all over V. This implies that 1 all over v is equal to what? 1 all over f minus 1 all over u. So this implies that 1 all over v is equal to what? 1 all over what? 15 minus 1 all over what? 20. So this implies that 1 all over v is equal to what? 1 all over what? 15 minus 1 all over what? 20. We take the LCM. This and this will give you what? 300. 300 into this will give you what? 20. This into this will give you what? 15. So 1 all over v is equal to what? 5 divided by what? 300. However, you're not looking for 1 all over v, you have to reciprocate your v. So you have your v is equal to what? 300 divided by 5. That's supposed to give us 60. Let me try and see. Divided by 5. Yes, I'm correct. Therefore, our v is equal to what? 60.0 what? cm. So that is, we are done with v. The next thing is the magnification of the mirror. Magnification m for the first video I told is v all over what? U. So this implies that m is equal to what? 60 divided by what? 20. This go, and 6 by 2 is what? 3. So therefore, your magnification m is what? 3. I told you magnification of mirror is a dimensionless quantity. It has no SI units. As simple as ABCD. Grab a copy of this book to do more of this. Let's pick another question from this book. We are picking question 13, page 87. I believe this is well explained. Good. Let's move on. Question number 13 from page 87, complete workbook in physics by Ashomon A.O. We have question number 13 as follows. I read. A magnified erect image is 4 times the size of the object placed in front of a concave mirror, whose focal length is 12 cm. What is the distance between the image formed and the pole of the mirror? So let's collect our data. From here, it's given us our I, which is equal to what? V, is given us what? They say a magnified erect image is 4 times the size of the object, meaning we have our I is equal to V equals to 4u, 4 times u. And then we have our focal length F giving us what? 12 cm. Good. 12 cm. And then they ask us to find the distance between the image formed and the pole of the mirror. They ask us to find V. V is not given. This is a word problem leading to physical, mathematical equation. So let's go straight to the point. So from 1 all over f, solution. From 1 all over f is equal to 1 all over u plus 1 all over v. This implies that 1 all over what? Over 12 is equal to what? 1 all over u plus 1 all over u plus 1 all over what? Your v is defined as 4u. So you write 4u. The next thing is to find the LCM of u and 4u. So this implies that 1 all over 12 is equals to 1 all over u plus 1 all over 4u divide by what? 4u. 4u into u will give you 4. Bring this one down, plus. 4u into 4u will give you 1. So, this implies that 1 all over 12 is equal to what? 4 plus 1 will give you 5. 5 divided by what? 4u. You cross multiply. So this implies that 1 times 4u, you have 4u is equal to 5 times 12. So you have 5 times what? 12. You are looking for u. So you divide both sides by 4. Both sides by 4. This will go, this will go. Your u is equal to 4 here, 1, 4 here, 3. So you have u is equal to what? 5 times what? 3. Therefore, the object distance u is given as what? 5 times 3. That is 15. 15 what? cm. As simple as that. But they say we should find v. V is not given. You may go back to this equation and put in the value of u, the value of f, and then find v, but that is long route. The short is come back to this equation. So you say, but I is equal to v is equal to what? 4u. So this implies that the image distance v, you know, 4 times what? 4 times what? 15. That will give us what? 4 times 15, that will give us 60. So therefore, v is given as what? 60.0 what? cm. As simple as A, B, C. I want to pick a question. I'll put this beside for now. I want to pick some questions here in my all-inclusive calculations in physics. I want to pick question number 24. Question number 24, page 282 reads, a concave mirror has a radius of curvature of 36 cm, full stop. At what distance from the mirror should an object be placed to give a real image 3 times the size of the object? This is a jump question. So, very, very simple. Let's go straight to the point. Good. So let's collect our data. This is question number 24. Question number what? 24 from all-inclusive calculation in physics. So our R is given as what? Our R is given as 36 cm. At what distance from the mirror should an object? The guys are asking to calculate U. U is not given. And they say that our V is given to be what? If the real image is 3 times the sum, V is what? 3U. So they ask us to find U. U is not given. If you look very well in this question, F also is not given. But if you watch the video I just produced, the video series I'm producing, you know how to get your F from this topic. You know that, let's start solution. F is given as R all over 2. That's a fact. So this implies that our focal length is what? 36 divided by 2. And that will give you what? 15, 16, 17. That will give you 18. 36 divided by 2. 36 by 2. That will give you 18. I was correct. 5, F equals what? 18 what? cm. At this point, you are free to substitute now. So we have F, we have U, V, sorry. So from 1 all over F is equal to 1 all over U. plus 1 all over V, we write that 1 all over what? 18 is equal to what? 1 all over U plus 1 all over what? V is 3U. 1 over 3U. So we make 1 over U the subject of the formula. We collect like terms. So we have 1 all over 18 is equal to what? 1 all over U plus 1 all over what? 3U. The LCM there is simply what? 3 what? U. 3U into this will give you what? 3. You bring this plus down, and 3 into this will give you what? 1. So you have 1 all over 18 is equal to what? 3 plus this, that is 4. You have 4 all over what? 3 what? U. You cross multiply. So you have 18 times 4 is equal to what? 3U. So your U, you divide both sides by 3, both sides by 3, this go, so that your U is what? Your U is 18 times 4 divided by 3. You have 72. This has to do 72. 72 divided by 3. 72 by 3. 72 by 3. That will give you, so therefore, your U is what? 24 cm. As simple as that. As simple as A, B, C. I want us to solve another question. Good. Page 282, question number 26, all-inclusive calculation in physics. Don't forget to subscribe to this channel and share this video to those that need it. Subscribe and promote this channel, and God will bless you. Subscribe and promote this channel, and God will bless you. Question number 26, page 282. Question number 26, I read. A real image 3 times the size of the object is formed 24 from a converging mirror. What is the focal length? What is the focal length of the mirror? It's running around the same mountain. Very, very simple. Let's collect our data. A real image 3 times the size of the object. I is equal to V is equal to what? 3U. That is the meaning of that statement. A real image is 3 times the size of the object. Is 3 times, a real image 3 times the size of an object is formed. So, a real image 3 times the size of an object is formed 24 from a converging mirror. So, our V is also given to be what? To be 24. Yes. So from here it implies that 24 is equal to what? 3U. Am I correct? So that we divide both sides by 3. Both sides by what? 3. And then your U is 24 by 3. That is 8. Our U is what? 8 what? cm. But that is not what they are asking us to do. To have this information, They want us to find the focal length. The focal length of the mirror. So our F is not given. So from here, 1 all over f is given as what? 1 all over u plus 1 all over what? V. So this information means this is equal to what? 24. That is the meaning of that statement. What a confusing question, but I believe we have gotten what the question is talking about. So 1 over f is given as what? 1 all over u. Your u is what? Your u is 8 from this analysis. And 1 all over v. Your v is what? 24. 24. So you take the LCM. 24 into 8. 24 into 8 will give you 3. And 24 into 24 will give you 1. So you have 1 all over f is equal to what? 4 divided by what? 24. You reciprocate. So your f is given as what? 24 divided by what? 4. And your f is given as what? 6 cm. I guess that is supposed to be the answer. Yes, we got it. The answer is C, 6 cm. Clap for me. So, let us solve one more question and then we'll call it a day. So I read this one. The magnification, question 29, I read. The magnification, this I'll read it out for you to go and solve. The magnification of the object, the magnification of the image of an object placed in front of a convex mirror is 1 over 3. If the radius of curvature of the mirror is 24 cm, what is the distance between the object and its image? Solve this question and drop your answer in the comment box. I read it again. The magnification of the image of an object placed in front of a convex mirror is 1 over 3, full stop. If the radius of curvature of the mirror is 24 cm, what is the distance between the object and its image? Solve this question following everything I've done in this video and drop your answer in the comment box. Don't forget to subscribe and share this video. With this, we have come to the end of today's lesson. Bye bye and God bless you.